is on sketching the derivative, velocity, and other rates of change. Okay, so basically, calculus is the study of rates of change. We do that the entire first semester. Anytime we talk about derivatives, it's a rate of change. So when you have science graphs that have things like, oh, it's the number of gallons per minute that we're losing, or the number of feet that we're increasing by each second, right? These are all calculus type graphs. It involves a rate of change, so therefore it involves calculus. So geometrically, f prime is the slope of the tangent line of f at each point x comma f of x. And it says the domain of f prime might be smaller than the domain of f. So basically when we're sketching a graph that's a derivative, we're going to look first for all the places where our slope is equal to 0. So this is our original function. So this is like the f of x function. Okay, and I'm going to go through, and on top of it, I'm going to graph what f prime looks like. So it's going to be on the same grid. Can we handle that? Okay, so where is the slope equal to 0 on this graph? So give me a couple x values where the slope is equal to 0.
X equals
-1, -3. Anything else?
4.5 maybe?
Yeah, between like 1 and 3 somewhere. I would think it looks around like at 2. Do you guys see how it kind of tapers off to a slope of 0? And 4. Yes, I agree. So these are all the locations where our slope is equal to 0. So if I was doing like a t-table almost for slope, I would be like, oh, well, for my f prime graph, at -3 I have a slope of 0. At -1 I have a slope of 0. At 2 I have a slope of 0. And at 4 I have a slope of 0. Okay, we're not always going to write this like little t-table. I'm just kind of illustrating this for a point. Okay, so we have these points on our f prime, which will look like this. -3, comma 0. -1, comma 0. 2, comma 0. And 4, comma 0. Okay. Now from here, we just want to know if our slope is positive or negative. So is f prime positive or negative? That's what we're trying to decide. So on this interval from here to here, does the graph go up or does it go down? It goes down. So what does that mean about f prime?
Negative.
F prime is negative. So when I graph f prime, I'm going to have all negative numbers. And it's tapering off to a slope of 0. Okay, so what's going to happen is it's going to be below the axis until we get to -3. Then what's happening? Well, now f prime is positive, right? So if f prime is positive, I'm going to be above the axis until it tapers off. It's getting closer and closer to 0. Like it's tapering off, like, you know what I'm saying by tapering off? Like these slopes are getting smaller and smaller. So if it's tapering off to a slope of 0, so it's going back towards y equals 0 for f prime. Does that make sense? You get it? You don't have to worry about how high or low it goes. Just kind of do this general connecting these 0 slopes. All right, then is my slope negative or positive?
Negative.
Negative. What about after 2? Negative or positive? Negative. So what's this mean for my graph of f prime? It kind of bounces. It has like multiplicity almost, right? So it's going to come around, it's going to bounce, and then it's going to go back down until we get to 4. And then we are positive from there. Our slope is positive, so we have to be above the axis. Okay, so this is kind of confusing for students to understand. So here's what we're going to think about it as. So every time we're doing this, in the future, we're going to use what we call critical values. You guys remember talking about critical values in Algebra 2 and Pre-Calc? And I usually label my graph f prime. Now the sad part is, when you draw this on the AP exam, they actually don't grade it. So we'd have to describe this if we were going to need like a justification for our answer or whatever. We'd have to say, well, f prime is positive on this interval and negative on this interval. We'll talk about that a lot throughout the year. But anyway, so all I do is I look at my original function and I decide if I'm increasing or decreasing. So I'm decreasing, I'm increasing, I'm decreasing and then decreasing again, and then I'm increasing. Do you see what I mean by that? So I'm going down, up, down, down again, and then up, right? And then that allows you to kind of sketch a rough graph. So you can say, oh, well that means I'm downwards, upwards, downwards, downwards again, and then upwards. So if I was trying to sketch the graph of what f will look like, so if I only had the derivative and I was going back, it would look like this. Down, up, down, down again, and then up. Is that kind of what our graph looks like, the original graph?
Yeah.
Yeah. So we can learn a lot from our graphs of derivatives and the original function. We can go back and forth between them. Does that kind of make sense?
The problems that will be given, will they only give us like the derivative?
They'll give you both. So sometimes you'll have the graph of the derivative and you'll need to sketch the original. Sometimes you'll have the graph of the Original, you need to sketch the derivative. Okay, the only thing we can't tell without more information is like if I have the derivative and I'm trying to go back to the original like I just did down here in the blue graph, I don't know where like the starting point is. I don't know how high or low it is. I just know kind of the basic ups and downs, right? All right, so this one. So I'm not going to go through a lot of work here. All I'm going to do is I'm going to first identify where f prime is equal to 0. So f prime is equal to 0 here, 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 and here. Is that all the places? Yeah, so we're going to put those on the axis for our graph of f prime. So my blue one was f prime of x there. All right, now I'm deciding if f is increasing or decreasing. So tell me what f does. Does it go up, down, up? What's it doing? Up, down, up, down, up. So what does that mean for f prime? It means I'm above the axis, below the axis, above the axis, below the axis, above the axis. Do you see what I'm saying? So I'm above, below, above, below, above. That's it. That would be a rough sketch of the derivative. So you can label that as f prime of x. Now this should make sense to you guys. Yeah.
Be like f prime of f prime.
No, this was f of x. The original is f of x.
Because that pretty much looks exactly like the one we just graphed in the other one.
They're very similar, yeah.
The red and the blue.
Yeah, I mean, the end behavior here is up and up, right? All right, so let's think about some basic ones. So you don't have to draw this, just kind of look up here. What about y equals x squared? What's its derivative? 2x. Well, let's think about it. 0, right? That's where the slope is 0. It's decreasing and then increasing. Decreasing, increasing. Does that look like y equals 2x, or y prime is 2x? Yeah, that's the graph of y equals 2x, right? Does that make sense? X cubed. Where does it taper off to a slope of 0? Yep. So at 0, it's increasing and increasing. So what does that mean for f prime? It means that it's above and above. So it has that like little multiplicity thing. Does that look like 3x squared? Yeah. So if you think about some of the basics, it helps. All right, so moving on. So it says in physics, you learn that a particle can travel a certain distance from a starting point. So this is called the displacement function, okay? It's going to have units like meters or feet. So sometimes we call this the position function. So it's just talking about where it's located, often along an axis, which I always think is funny because the AP test will say things like, a particle moves along the x-axis. And so it means, okay, the particle's moved to a distance of 3, and then it moved back to -2. So it's kind of like a number line situation. I didn't draw that very well, but so you move forwards and backwards and forwards and backwards. Is that how like real life is? Do we just move along a line? Like, am I stuck on this horizontal line forever? And I can only walk forwards and backwards. I can never get to Nick. Like, I can never touch him because I'm just walking on this horizontal line. No, it doesn't make any sense, right? But that's how a lot of the AP questions are. All right, so anyway, so we're talking about a location along like an axis, basically. When we take the derivative, we're finding a rate of change. So now it's going to be meters per something, so meters per second, miles per hour, feet per second, right? That's going to be the velocity function. And then finally, if you take the derivative of velocity, we get the acceleration. So I kind of mentioned this the other day. So if you start with your displacement function, s of t, s prime of t is the velocity function, and s double prime of t is the acceleration. I always had to remember SVA. I don't know why when I was in school. I had to write SVA every single time. Position, velocity, acceleration. If you ever see the AP test ask for speed, we just use the fact that speed is the absolute value of velocity. Okay, so I'm never going to say that I go at a speed of -2 meters per second. That doesn't work. I can't have a negative for speed. All right, you good? All right, so number 1, so it says the equation of motion or position is s equals t cubed minus 3t. Find the velocity and acceleration. So our velocity function is going to be s prime of t. So we're going to take the derivative of this function. So we take the derivative, we get 3t squared minus 3. Easy, right? Acceleration, take the derivative of s prime. So we have s double prime. We get 6t. So then I can ask lots of questions about it. So the first one says, we'll find the acceleration after 2 seconds. That means find the acceleration at time t equals 2. A of 2. What do we get? 12, because we get 6 times 2, which is 12. And then we look for our units. So we had meters and we had seconds. So the original position was in meters. Our velocity is in meters per second, and our acceleration is meters per second, which is meters per second squared. Exactly. So those of you that have had physics, you're going to think this is the easiest section ever. If you haven't had physics, you're going to be like, wait, what? I stupidly took non-calculus-based physics in college. Why did I do that? Like, calc-based physics is so much easier because you can use calculus. If you do non-calculus-based physics, you get all these weird formulas that you have to memorize that it's just much easier just to take the derivative. So that was dumb of me. All right, so anyway, so I get 12 meters per second squared. All right, so the velocity of a unicycle is shown below. Use the graph to answer the questions. So at what time or times is the unicycle stopped? So this is the velocity function. Did I skip something?
Yes.
Oh, I thought I had more questions with that. Maybe I need to scroll down. Oh, okay, the acceleration when velocity is equal to 0. So we want to find when the velocity, v of t, is equal to 0. So v of t is 3t squared minus 3 equals 0. Can you guys already tell what t is going to equal? T equals plus or minus 1. Does one of those not make sense when we talk about the world? Yeah, can't have negative time. We're not going backwards in time. So t equals 1 second. So our question is, well, find the acceleration when that happens. So find the acceleration when the time is equal to 1. So we find a of 1, which is 6 times 1. So we get 6 meters per second squared. All right, now I'm good there. Okay, going back to the unicycle one. So the velocity of a unicycle is shown below. At what time or times is the unicycle stopped? So this is the velocity function. Okay, velocity is in things like meters per second. In this case, it's meters per minute. You're going slowly on this little unicycle. We used to have a student a few years ago. He was brilliant in calculus, but he did a talent show. Have you guys seen university talent shows? Yeah, you've seen university. Sometimes they're great. Sometimes we're like, okay, that's very interesting. But there was, his was the most fascinating thing I've ever seen at a talent show because he rode on a unicycle and he juggled fire. And I was like, okay, you're talented. I was like, that is amazing. So that happened a few years ago. J.D. Hoover. So it's Ellie Hoover. Do you guys remember Ellie Hoover? Yeah, it's her older brother. All right, so A, so at what time or times is a unicycle stopped? So what are we looking for? We're looking for when the velocity is equal to 0. So we write that on our paper. So on the AP test, you got to write things down. You have to. You get points for writing things down. Points for your work. So what time is a unicycle stopped? So our velocity equals 0 right there and right there. So I'm going to say at time 30 minutes, right, and 50 minutes. When is the unicycle going backwards? So what does that mean, going backwards? What are we looking for?
5 minutes.
Oh, is it 55? Yes, thank you. Darn, you got me. 55 minutes. So when is it going backwards? What's negative? The velocity, right? So we're going to say velocity is less than 0. We write that down. So when is our velocity less than 0? From here to here. So we're going to say on this interval, right? So between t equals this and t equals this. So we're going to say it's going backwards on the interval 30 to 55. That works. Or you could write from time t equals 30 minutes to 55 minutes. What is the acceleration at 30 minutes? I don't know. What is it? So how is acceleration related to the graph that we were given? Acceleration is the slope. So we want to find v prime of 30, which is the slope at t equals 30. Now these are just line segments. It's not hard to find the slope. So we got to count. We're going to say rise over run or whatever, as we always say. The science teachers apparently hate when we say that. But we want to know how much it's going down and over. And you want to be really careful because sometimes the units aren't the same on the x and the y axis, right? So how much did we go down and how much did we go over? We went down 20 and over 5, right? So our slope is negative 20 over 5, which is negative 4. And what are our units?
I
should say that.
Meters per minute squared.
Yeah, now it's meters per, not minutes squared though. Oh yeah, it is acceleration, minutes squared, yes. Thank you. All right, and then what is the speed at 35 minutes? So speed is the absolute value of velocity. So we want to find the velocity at 35 minutes, and then we're going to take the absolute value of it. So we find 35, we're right here. Its velocity is negative 20, right? Absolute value is 20 meters per minute. Okay, so it's not the slope, it's the y value on that graph. Does that make sense? Okay, we have lots of those in the AP test. Okay, when is the acceleration the greatest? Ooh, that's hard. Acceleration is the greatest. Acceleration is the slope, right? So we're going to go through and we're going to look for the steepest slope. What do we think, 0 to 10? Is that the steepest? So we went up 60 and over 10. The slope is 6 there. Do we beat it anywhere else? What about the slope here? No, it's not. It doesn't even look as steep, right? So yeah, our slope is, the acceleration is the greatest on the interval 0 to 10. We would say on for intervals, at for points. Okay. So when you're driving a car, the velocity, or the speed, or velocity, I didn't use that very well, did I? Is constantly changing. There's a definite velocity for each moment, which we have referred to as the instantaneous velocity. Okay. So, all right. Let's start with average velocity. This is related to average rate of change. Do you guys remember average rate of change? There's a formula for it.
Isn't it like PE?
Is it what?
PE. PRT.
No, you learned it this year. Average rate of change. Average rate of change. Yes, thank you, Lydia. You've given me hope in this class. I even made you guys the flashcards. I made them for you, and you still don't look at them. F of B minus F of A all over B minus A. Correct. Okay, that is the average rate of change. That's our average rate of change formula. But for average velocity, what is the rate of change of? The rate of change of velocity? Average rate of change of position, because it's the slope of the position function. Do you guys understand what I'm saying? Do you guys know how average rate of change, that's slope? You guys get that? It's the slope of the position function. So we're going to write average rate of change of the position function. So instead of using f's, I'm going to come in here and I'm going to erase, and I'm going to write what? S. Sometimes you'll see x's used as well, like x of b minus x of a. That's usually when it's along an x-axis they'll talk about. All right, instantaneous velocity. Well, this is also slope, but this is the slope basically at a single point. It's like when you take those points and you move them, you scooch them closer and closer together with a limit. So this is going to be s prime at that certain x value, which is, in other words, is your velocity at x, or t, or whatever you want to do. All right, so this is very important for the AP test. So if they ask for average rate of change, you use the average rate of change formula. But if they ask for the instantaneous rate of change, you need f prime of that number, okay? So it's talking about at a certain point. So number one, so it says if a ball is thrown in the air with a velocity of 40 feet per second, its height in feet t seconds after it is given, t seconds later is given by y equals 40t minus 16t squared. So find the average velocity starting with time t equals 2 and lasting 0.5 seconds. So we're finding it between t equals 2 and t equals, if it lasts 0.5 seconds, 2.5, okay? And we're finding the average velocity, which is the average rate of change of the position. So in this case, I use y for my position. Don't let that throw you. If it doesn't say s or x or whatever, it can say like y. It can say f of x for position. It could say p of x. We don't know. So what I'm going to do is I'm going to find y of 2.5 minus y of 2 all over 2.5 minus 2. I don't think so. Is it 2? I don't know. All right, so let's use our calculator. So when I have a lot of these things that I have to plug into the same function, I always use my table. So I'm going to go to my y equals, and I'm going to put in 40 x minus 16 x squared. You guys good? I'm going to go to my table, and I'm going to put in these values. Make this so it's ask. So second table. So I'm going to put in 2.5, and I'm going to put in 2. So when I plugged in 2.5, I got 0. And when I plugged in 2, I got 16. Is that what it said? 16. And then I divide by 0.5. So what do we get for the average velocity? Did I do something wrong? You guys are looking at me crazy.
32.
Negative 32? Yeah, so negative 32. Okay, so let's think about the units. Y of 2.5 and y of 2, what were the units for our numerator? What were our units here? Look at y. It's in feet, because that's a position, and it said we had a velocity of 40 feet per second, right? So this is in feet. What was this in? It was in seconds, right? So our final answer is in feet per second. Does that make sense why it would be feet per second? Yeah, we were finding the average velocity, right? It better be feet per second. All right, so if I last 0.1 seconds, then I'm going between 2 and 2.1. And I do the same thing. So I'm kind of taking my limit and I'm getting closer. Remember those when we used to do tables of values and we plug in 0.1, 0.01, 0.001. That's kind of what we're doing. So we're going to find y of 2.1 minus y of 2 all over 2.1 minus 2. So if we go back to our table and we put in 2.1, we get 13.44. And you can arrow over to make sure that's all your decimals. It is 13.44. Minus 16 all over 0.1. So we can do that. 13.44 minus 16 equals, divide by by 0.1. What do we get? Negative 25.6. Still, feet per second. Yeah, I go back and forth between writing S for seconds or SEC. All right, then 0.01 seconds. Well, let's do that as well. So if I go back to my table and I put in 2.01, I get the lovely 15.7584 minus that 16 all over 0.1. 15 point. Oh, divided by 0.1, thank you.
Or 0.0.
Yeah, I gotcha. Divided by 0.01, thank you. So we get negative 24.16. And this is in feet per second. So what does it look like it's getting closer to? I don't know. Maybe negative 24, I don't know. You'd have to do quite a few to see that it's going towards negative 24. So it says, well, let's find the instantaneous velocity. So when you see instantaneous, that's a derivative. So we're going to take our position function, which was 40t minus 16t squared, and we're going to take the derivative to get our velocity function. So I get 40 minus 24t. So if I find my velocity at time 2, well, 24, 32. I was like doing some kind of, I was crazy. I don't know. So I was trying to say I'm going to get 24 in the end, but I don't know. Maybe I'm not. All right, so I get 40 minus 32. Yeah, so I have y prime of 2, which is 40 minus 32 times 2. So we get 40 minus 64, which is indeed negative 24 feet per second. Does that make sense? So that's the instantaneous velocity. So if we had done that limiting process and we did 0.001, 0.0001, 0.0001, we would get it. Yeah.
So on the AP test, you said we had to write 3 decimals.
Mm-hmm.
What if it only, on your calculator, only comes to 1?
So like negative 25.6, you just leave as that. If it's already like, it's not been rounded at all, right? That was the exact answer, then you just leave it.
Don't round to the final.
Yeah, don't round to the very end, yeah. No intermediate rounding, right? All right, so when is the velocity equal to 30 feet per second? Well, we have the velocity function. That was our 40 minus 32t we just found. So we set it equal to 30. And we solve it out.
So
That's
you
it.
can do the, like you go ahead and use the derivative.
Yeah, because that was the velocity function, right? Does that make sense? So velocity is the derivative of the position function. So our position was our
yeah.
y equals.
Okay.
So I get negative 10 over negative 32, I believe, which is 5 over 16 seconds.
Which is 0.31.
Yeah, so on that one probably, I don't know if it comes out. I guess it would, 5 over 16. So yeah, you could do 0.313 or just leave it as 5 over 16. You can also truncate, which bothers me. I just feel like it's so wrong for people that are going to build my bridges and so on someday to just write 0.312, just truncating. I just feel like that's wrong. But you can do that as well. All right, making sense? All right, so let's move on to the econ stuff. How many of you guys are in econ right now? All right, so in econ, the word marginal is used to indicate a rate. So if you see something that says like marginal cost, it's the derivative of the cost function. Marginal profit is the derivative of the profit. So nowadays, new efficient machines allow the cost of a product to not be constant. Okay, so let's think about this. So I think I give an example. I don't know if I give this example, but my aunt sells necklaces, right? So she goes to these different like art festivals and stuff, and she sells necklaces and bracelets and so on. And she does them by hand. I always think it's funny because she's colorblind, which is rare for a woman to be colorblind. But so sometimes the colors are just, I don't know what she chooses the colors for, but she's got some good ones. But she makes these things, and if she had a machine that made necklaces for her, she would be able to produce a lot more necklaces, right? Does this make sense? Okay, but what happens when you buy a machine? It costs money. So if she buys a machine for $500,000, I don't know how much the machine would be, and then sells 3 necklaces, that doesn't make any sense, right? That's not good for her business. She would go out of business, okay?
Well, she'd also have to sell
Disagree with
necklaces for less because she's producing.
Yeah, she could produce more.
Not to
I don't know.
mention
So
handmade.
the cost of a product is not necessarily constant. So the more we're producing, right, if we have a machine, the cheaper it costs to produce it. However, there's that initial cost originally. So it says we can make a bunch of necklaces by hand, or we could purchase a machine to make them for us. But the second option is much more pricey. It just depends on the payout. If she's making a ton of money and she's on Etsy and she's selling it all over the world, then maybe it's worth it. Okay, so besides marginal cost, you could also see many other terms about the cost function in econ. So average cost is exactly what you think it is. So what do you guys think average cost would be? You just take the total cost and divide by the number that you produced, right? Does that make sense? So total cost divided by number of items. We write average cost as the lovely C of X bar. You all looked up like, what's bar? That's what bar is. It's a line over it.
Which means
It means average. So what this means is C of X divided by X.
C of X, C of X, C of X.
So it's the total cost divided by the number of items. Okay. So I'm gonna break down econ in this lovely example of a lemonade stand. Did you guys ever do lemonade stands? I did these all the time. I love lemonade stands. So think of the first time that you made money, a lemonade stand. So suppose you go to the store and your mom's like, I'm not funding your lemonade stand. You got to buy it with your own piggy bank money. And you take your piggy bank money and you buy 6 of the Country Time lemonade containers for $1.50 each. How much does that cost? Yeah, my mom is cheap. I agree. She would totally make me pay for it. So how much would it be? $9. Yes. So we have $9 there. With each container, you are able to make 60 cups of lemonade, which you then sell for 50 cents each, which any human should instead of dollar glasses of lemonade, which is the current going rate. $1 for a cup of lemonade, seriously? Whatever. So we're selling it for 50 cents each. So how much?
Try $2.
How much? I don't want to say how much do I make. How much is in the jar of money after that day of sales? I have 60 cups of lemonade, 50 cents each. I had $30, but how many of those containers did I have?
6.
I had 6. So my revenue, how much is in the collection jar? I made a killing. How much did I make?
$21.
What? You guys are just confused. I think it's $180, right?
$260.
You're saying 21? I don't know what you're saying. Because you have 60 cups of lemonade with each container. Each of those containers made you $30, and you had 6 containers.
That's if you sold them all.
But I did, because I'm really good at selling stuff. And I sold it for 50 cents, and people were like, 50-cent lemonade? I haven't seen that day in forever. All right.
How many
Wait,
each would be?
wait,
Be a lot of people.
have you seen those commercials?
Yeah.
With the lemonade tray, which is like, where you have to account for the
Yeah,
skipping
uh-huh,
my lawn
uh-huh.
tax and
However, this is not your profit, because what does your mom do? She's teaching you about business. She made you pay for your lemonade. So how much did you pay? You paid $9. So you end up with how much money?
only
171, which is still kind of a killing. Maybe this was a whole weekend. I don't know. All right, so the revenue is the amount of money that you're bringing in. That's the amount of money that's in that jar at the end of the day. Okay, in the jar, revenue. However, you have to pay people to help you. So sometimes you have to pay employees, sometimes you have to pay for machines, sometimes you have costs associated with things, right? So items, like you have to make things, you have to buy the jewelry, you have to buy the little clasps. So this does not include the cost of purchasing, so our profit is equal to the revenue minus cost. That is a very important thing in life. Profit equals revenue minus cost. All right, we good so far? All right, so let's go through this. So the cost of producing X units of a certain item is C of X equals 1/4 X squared plus 3X plus 67. The price at which each item will be sold is P of X equals 1/5 times 45 minus X. Suppose we sell all X items. Find our marginal cost. So what does marginal mean?
Average.
It means the derivative. So we're going to find C prime of X. So that's C prime of X. So we take the derivative of C of X and we get 2/4, which is 1/2 X plus 3. That's our marginal cost equation. All right, what is our average cost? Well, that's our C bar. Don't you like saying it? C bar. C of X divided by X. So we take our total cost, which was 1/4 X squared plus 3X plus 67, and we divide by X. So we get 1/4 X plus 3 plus 67 over X. I was like going back to my marginal cost. All right. Most of the time, these end up being pretty close. So if I talk about the cost of producing 100 items, they'll be pretty close to each other. Like maybe one's $6 and one of them's $5.98. I don't know. They could be very close. All right, find the revenue. So our revenue ends up being our number of items we sell, number sold, multiplied by the price per item. Right? Just like the lemonade stand. I sold, however many cups of lemonade at 50 cents each.
They sold
So I sold X items, and what was the price per item?
P.
P of X, right? Which was 1/5 times 45 minus X. Yeah. So 9 minus 1/5 X. So what do we get? 9X minus 1/5 X squared. That's our revenue. So we're going to write that as R of X. So revenue is always your price times your number sold. So P of X times X. Got a little sloppy in there. All right, marginal revenue. So this is like approximately like how much revenue you're bringing in per item.
It's a
Okay.
third derivative, not R. It's
Oh, dang it, I didn't know why I did that. Marginal revenue. So we're going to do R prime of X. It's hard to talk and write at the same time. All right, so how do I get this? I just take the derivative of what I just found. So I get 9 minus 2/5 X. All right, almost there. Profit.
Is revenue minus.
Revenue minus cost. You're going to remember this the rest of your life. You're going to be like, Mrs. Cox taught me this with lemonade. All right, revenue, amount of money we brought in, which was the 9X minus 1/5 X squared, minus our cost, which was, to go back, 1/4 x squared plus 3x plus 67. So we could clean it up a little bit.
So why are we using the
I think we
9x
should know
minus
this.
1/5 x squared if that's the derivative of
It wasn't the derivative, it was here.
It's just-
That's our revenue.
Yeah, I know. We took the derivative of the p.
Is it 9 over 20? Help me.
Oh, no, no.
Minus 67, is that it? All right, the marginal profit. So P prime of x is 6 minus 18 over 20, so 9 over 10. X. That's it. Okay. So now let's do one with actual numbers, because it doesn't make any sense when we don't use numbers. But that's how you find each of those things. So then I could say, what's the marginal profit for 100 units? What's the revenue for 200 units? Okay, so let's try this next one. So suppose that this is the total cost for a company to produce X units of a certain product. Math books, these never make sense where these come from, so don't try to figure out what this equation is. They're just giving you an equation. All right, compute the marginal cost at x equals 100 and compare this to the actual cost of producing the 100th unit. This is a tricky question.
So you have to find the derivative first.
So you need to find the derivative, which ends up being 0.04x plus 2. And we find that for 100 items. So what do we get? 6. So what that means is that for each item, it's costing us around $6 to produce. Okay? So we would want to sell it for something more than $6.
Maybe 8.
Yeah, maybe 8 or 20. All right, but then, this is econ. This is why you should take econ, because what if you decide I'm going to sell it for $100, then I get a profit of $94 for each item. What happens then? People don't buy it because it's not worth $100, right? So you have to find that magic point, the best point. All right, so the actual cost of producing the 100th unit. So that 100th unit, so each item is not necessarily costing $6. Maybe the first item costs a lot to produce because you bought this big machine for that first item and you only produced one thing. But then the second item is, oh, well, now we're producing 2 things, and then 3, and then 4, and then 5. So then the cost of the 100th item might be less. We don't know. Okay? Or maybe I have the opposite, where I'm creating more items and now I have to hire more people to help me, right? And I'm paying more people to help. And it's well, I should have just done this myself. I shouldn't hire all these people or pay them overtime and so on. Does this make sense? Okay, so what is the actual cost of producing the single 100th unit? How can we find that? It's a tricky one. Do we just find the cost of 100, C of 100? What does that represent? That represents the cost of producing the first 100 units, right? Does that make sense? So if I want only the 100th unit, how can I find that? Yes, I can find the cost of the 100 units and subtract out the cost of 99 units. And that gives me the single 100th unit. Does this make sense? Is this a little bit harder to do without a calculator? I did all that last one without a calculator. Do I want to do 99 squared times 0.02 plus 2 times 99 plus 4,000 without a calculator? I really don't. So I'm going to put it into my table. And I'm going to put in this cost function. So 0.02 x squared plus 2x plus 4,000. Did I have enough? 1, 2, 3? Okay. And then I go to my table, and I want to find the cost of 100 total items and the cost of 99 total items.
Why not just do the cost of 1?
Because it doesn't work that way. So we can find that as well. What's the cost of 1? Because remember, the first item might be way more expensive to produce than the other items. So the cost of the 100 items is $4,400. The cost of the other one is $43.94.02.
Oh, I did not get one.
You got to arrow over. You see it? So what do we get? $5.98. Is that pretty darn close?
Yeah.
Yeah, which one was easier?
First one.
The first one, because we didn't have to use a calculator, right? So this is why we use derivatives in the business world, because derivatives are much faster to compute. They're always 1 degree less than what we had, right? It's faster to plug things in for derivatives. So we just use derivatives most of the time. All right, so B, find the production level that minimizes the average cost. Ooh, average cost. So what's our average cost look like? C bar, that's our total cost divided by X. So we take our 0.02x squared plus 2x plus 4,000, and we divide everything through by X. So we get 0.02x plus 2 plus 4,000 over X. So if we have our calculator, we could graph that, and we could find the minimum. But if we didn't have our calculator, how do I find a minimum of a function? No, didn't I do this the other day? Like if I was finding the minimum of a parabola, do you guys remember in Algebra 2 when you found the minimum? You did a x equals negative b over 2a, right? This isn't a parabola function, though, that we have. Didn't I show you how we got the negative b over 2a with calculus?
Yeah, it's the
Yeah, you took the derivative, and then you set it equal to 0. That's what we're doing. So if I have some kind of curve, if I'm going to find maximums and minimums, that's where my horizontal tangents are occurring, right? So I just do that. I find the derivative, and I set it equal to 0. So I do C bar prime, and I set it equal to 0. But remember, that can be a maximum or a minimum. So technically, to test to see if something's a maximum or minimum, you want to show that it increases and then decreases would be a maximum. Decreases and then increases would be a minimum. So in this case, it's probably easiest just use your calculator. All right, so let's stop there. And I'll